Welcome to the Earth Science Classroom, everyone. Welcome back. So we're into earthquakes, rock deformation, video 2. Video 1 looked at this kind of flow chart. We started with crustal rocks in the top left, and we started to add stress, and then the strain was discussed, deformation, the change of shape and size, and then eventually with continued stress applied on that rock, you would actually get a rupture or fracture, and that's what we need to have movement either side of a fracture that we call a fault line, and this would result in potentially earthquakes in the crust, which is what our whole video is about, looking at earthquakes, how they form, what they are, and how we study them. All right, so guys, welcome. So in this video, we're going to look in more detail at the deformation part, because we did stress and strain in the previous video, and obviously what a rupture or fracture looks like in a rock, and the consequential fault line, and why it's so important in terms of earthquakes. All right, so we're on to deformation. That is the change of shape or size of the rock, and that happens after stress and strain. So, but deformation happens in, or could happen to the rock in 3 different ways. There's always more variations in the process. It's not just as simple as deformation. So the 3 different ways is, well, first is elastic deformation. I'll put DEF. Okay, then we got ductile, DEF, or deformation. And the last one is brittle. Now, I did mention this in the first video about the crustal rocks in the top 15 kilometers of the crust are more brittle than the ones lower based on heat and pressure. So we're going to look at that in more detail. So now, what is elastic? Okay, so it's bendy. You can basically move it and it goes back to its original position, shape, and size. Goes back once you bend it. So think of a plastic ruler in the classroom. Okay, you can bend it, but not so much that you create a consistent or permanent bend in the ruler, but enough that you can basically bend it, enough force, bend it, and it comes back to its original position. Okay, it doesn't get misshapen or anyway. So that's elastic. Okay, and then we get ductile. Ductile is exactly that. You add more force or stress to the ruler, say the ruler again, okay, and you permanently bent the ruler, and it does not go back to its original shape. You have forever bent the ruler, okay? So that is ductile. So you add more stress and more force applied, going beyond the elastic capability or threshold. Okay, there's a elastic point. There's a point in which that ruler turns from elastic to ductile. And then the last one is brittle. Okay, so this one basically is, again, you are increasing the stress and the strain, okay, beyond, let's say, the elastic and the ductile thresholds of that ruler, and you are going to physically break or rupture the ruler. So now you have 2 rulers, okay, completely useless or less measure with, but you're now 2 rulers. So you've broken the ruler, you've applied enough stress and force to it that it breaks. Okay, so that's definitions. Now, again, we use graphs in earth science, to represent the information. We use data and graphs, just like in math. We use the math to back up and show the science at work. All right, so we have our basic graph, our XY graph, and we see the strain on the x-axis and the stress on the y-axis. So we know that there is a relationship um, to these two different characteristics, or these two things about rocks. So let's look at this. So we start here, okay? Basically zero stress and zero strain. That rock is just, there's nothing applied to that rock. It's the beginning. So it's the starting point, okay? The starting point, okay, with our rock. Then we add the stress. So every rock is going to have this part where you're going to have the stress increases and you're going to have a little bit of strain. So there's more stress, a little bit of strain. Okay, see that? So it goes up to here. There's more stress with less strain, but it's only small amount difference. Okay, and this is our elastic deformation. Now, most rocks have a component, a starting point where they go through an elastic deformation where if there's enough stress applied that it moves, but not enough that it's going to permanently deform or reshape the rock or break it. So there's going to be some elastic nature characteristics about each rock. Okay, then you get to what's called the elastic limit, a little X there. Okay, so the elastic limit. Okay, the max stress or the max elastic capability that rock can do, okay, under the stress applied. Now, it can change with each rock, change with depths and temperature, but generally there's an elastic limit. Then what happens is the ductile portion starts to take control and keep the stress going. You get the ductile. Again, goes up to a point where there is a ductile limit for each rock. Okay, so this is ductile. All right, so you can also put in here, bendy. You can bend it, and then this is bent, so it's permanent. And then the last one, we use green right here, is it turns into a very short. Okay, and this is our brittle. Brittle is usually not a large opponent, doesn't take too much more stress. Maybe it's like it could be up here or up here, depends on the rock. But the stress is increased. But look at the strain, a lot more strain. Okay, so what you get is you get this area here coming down where you have the permanent strain, the permanent effect. So it is changed size or shape. So this area right here, I'll just do a little gray. Anything this side, okay? Okay, you're going to have that permanent strain, that shape on that rock, okay? So, again, anything on this side of the graph, the rock is broken. It's broken, it is ruptured, okay? And we call this a fracture. The rock has fractured, has broken, okay? And if you get a consistent fracture through the rock, what happens is you create a fault line. Just don't forget, you create a fault, which looks like this. So you have your rock, okay? Goes through stages of stress and strain and deformation and gets to the brittle area. What happens is you get this crack. You get this crack going through the rock because of the stress, because of the strain, because of the deformation you see in the left-hand side with this table, this graph, okay? And you create a rupture or a fracture, okay, which we call a fault, all right? And the movement, the stress applied doesn't stop when the fracture is created. The earth doesn't just stop when the rock breaks, it is continuous. So you have continuous stress applied, which equals movement. So there's still movement there. So this one could be moving this way. This one could be moving this way. And you get this movement along the fault line. That is the dividing point between the two rocks that have just broken. And this is the formation. This is the genesis of earthquakes. All right. So guys, I hope you enjoyed this video. I hope you can see it. And I'm going to go back to up here, and you can see that my flow chart, we have looked at every piece of the flow chart in detail, and we have come up to the fault line. And the next video we'll look at is the different kinds of faults we get and how they can create earthquakes. All right. So guys, thank you so much for everyone for listening, and hope you subscribe to the channel for more videos, more amazing earth science processes and natural phenomena, and we're trying to explain them and allow the teachers to explain them in a way that all the students hopefully can understand and apply.